The F-117 Nighthawk was unlike anything the world had ever seen. A jet that defied conventional aerodynamics, it was built not for speed or dogfights, but for invisibility. With its angular design, radar-absorbing materials, and cutting-edge technology, it could slip behind enemy lines undetected, striking with pinpoint accuracy. But how did engineers turn an unstable, faceted shape into a deadly war machine? In this video, we'll uncover the mind-blowing engineering secrets of the F-117 Nighthawk. But before that, subscribe to our channel and hit the bell icon for regular updates. Now, let's get started. The birth of the hopeless diamond. The journey of the F-117 began with a translated Russian scientific paper. In the 1970s, Soviet advancements in radar-guided missile technology had made traditional aircraft highly vulnerable. The U.S. military realized it needed a new kind of aircraft, one that could penetrate enemy defenses without being detected. Lockheed's Skunk Works, the secretive division behind some of the most advanced aircraft in history, took on the challenge. A team led by Ben Rich, the successor to the legendary Kelly Johnson, began working on stealth technology. The key breakthrough came from a mathematical method that allowed engineers to predict how an aircraft's shape would interact with radar waves. This led to the creation of a simple angular design that became known as the hopeless diamond due to its unconventional, faceted appearance. At first, many experts believed this design would never fly. It lacked smooth curves and traditional aerodynamics. However, through careful engineering, the team refined the shape into something that could both evade radar and stay in the air. The result was the F-117, a plane that defied conventional wisdom and rewrote the rules of aerial combat. The science behind invisibility. Stealth technology is all about reducing an aircraft's radar cross-section, RCS, making it appear as small as possible on enemy radar screens. The F-117 achieved this through a combination of shape, materials, and flight tactics. Its faceted design ensured that radar waves hitting the aircraft would be reflected away rather than returning to the enemy's radar receivers. Unlike traditional aircraft with smooth aerodynamic curves, the F-117 was covered in flat, angular panels, each carefully calculated to scatter electromagnetic energy. Beyond shape, the aircraft's skin was coated with radar-absorbent material, RAM. This special coating helped absorb radar waves rather than reflecting them. However, stealth alone wasn't enough. The F-117 also had to minimize other forms of detection. Its engines were hidden deep inside the fuselage, and its exhaust was cooled to reduce its infrared signature, making it harder for heat-seeking missiles to lock on. Even its mission planning was designed around stealth. Pilots flew along carefully planned routes that avoided known radar sites, and the aircraft only communicated using tight beam radio signals to minimize electronic emissions. Every aspect of the F-117's design and operation revolved around one goal: remaining invisible. How the F-117 stayed in the air. The F-117's radical design presented a major challenge. It was inherently unstable in flight. Traditional aircraft rely on smooth aerodynamics to maintain stability, but the Nighthawk's faceted shape disrupted airflow, making it nearly impossible to fly using conventional controls. To overcome this, Lockheed engineers equipped the F-117 with a fly-by-wire system, a computer-controlled flight system that constantly made tiny adjustments to keep the aircraft stable. Without this technology, even the most skilled pilot would struggle to control the plane. Another major challenge was its low-speed performance. The extreme sweep of its wings, 67.5 degrees, reduced lift, meaning the aircraft needed large control surfaces to maintain maneuverability. Its wings had to be oversized to compensate, giving it an unusual appearance. Unlike modern fighter jets designed for high-speed dogfights, the F-117 was a subsonic aircraft optimized for stealthy, high-precision bombing runs rather than aerial combat. Despite these limitations, the engineers at Skunk Works managed to turn a seemingly unworkable concept into a highly effective war machine. The F-117 wasn't designed to be fast or agile, it was designed to be undetectable, and in that role, it excelled. Engines and exhaust design. the F-117 was powered by two General Electric F-404 engines, the same type used in the F-18 Hornet. However, these engines were not equipped with afterburners, as the intense heat would make the aircraft easier to detect by infrared sensors. Instead, the F-117 relied on stealth tactics rather than speed to survive. One of the most unique aspects of the aircraft was its exhaust system. Heat from the engines was a major concern, as infrared-seeking missiles could easily track it. To counter this, the F-117 used a special flattened exhaust nozzle that spread the hot gases over a wider area, allowing them to cool more quickly. This significantly reduced the aircraft's infrared signature. Moreover, heat-absorbing ceramic tiles were placed around the exhaust area, further minimizing its thermal footprint. These tiles were similar to those used on space shuttles to withstand extreme temperatures. By carefully controlling how and where the heat was dispersed, engineers ensured the F-117 remained difficult to track, even with advanced infrared detection systems. The flight computer. Because of its unconventional shape, the F-117 relied heavily on its flight computer. The aircraft had no natural aerodynamic stability, meaning a human pilot alone couldn't control it. Instead, a digital fly-by-wire system constantly adjusted the control surfaces to keep the plane stable. This system took inputs from the pilot and translated them into precise movements. If the pilot pulled back on the stick, the computer calculated the safest way to achieve the desired motion. It prevented pilots from making aggressive maneuvers that could send the plane into an uncontrollable spin. Without this system, the F-117 would never have been able to fly. The weapons and mission profile. Unlike fighter jets that carry a variety of weapons, the F-117 was built for one job: precision strikes. It had no guns, no missiles, and could carry only two bombs. These bombs were either laser-guided or GPS-guided, ensuring pinpoint accuracy. The aircraft's targeting system used infrared cameras and laser designators. The pilot would lock onto a target using these cameras, and the bomb would follow the laser's reflection all the way to impact. This technology allowed the F-117 to hit high-value targets with extreme precision, minimizing collateral damage. However, it also had limitations. It couldn't operate effectively in bad weather, as clouds could block the laser's path. Combat legacy. The F-117 first saw combat during the 1989 U.S. invasion of Panama, but its true test came in the Gulf War. When the United States launched Operation Desert Storm in 1991, the F-117 was sent deep into enemy airspace to strike high-value targets. Its stealth capabilities allowed it to fly over heavily defended areas without being detected. It took part in over 1,600 missions, striking critical enemy infrastructure, command centers, and air defense sites, all without a single loss. The aircraft's ability to deliver precision-guided bombs with extreme accuracy made it a game-changer in modern warfare. However, as stealth technology became more widespread, enemy forces adapted. In 1999, during the Kosovo War, an F-117 was shot down by a Serbian surface-to-air missile. The aircraft's stealth wasn't perfect, and by using clever tactics, such as turning radar on and off unpredictably, enemy forces managed to locate and target it. This incident marked the beginning of the end for the F-117, as newer stealth aircraft like the F-22 Raptor and F-35 Lightning II were already in development. The end of an era in the future of stealth. By the early 2000s, the F-117 was being phased out. More advanced stealth aircraft with superior aerodynamics and multi-role capabilities had been developed, making the Nighthawk obsolete. In 2008, the F-117 was officially retired from active service, though some have reportedly been kept in storage and occasionally used for testing. The legacy of the F-117 lives on in modern stealth aircraft. The technology pioneered by Skunk Works paved the way for the F-22 Raptor and the F-35 Lightning II, both of which incorporate lessons learned from the Nighthawk's design. These newer aircraft maintain stealth while also being faster, more maneuverable, and better equipped for various combat roles. The F-117 was a bold experiment that paid off spectacularly. It proved that stealth technology could completely change the way wars were fought, allowing aircraft to operate in enemy territory without fear of detection. While it may no longer be in service, the engineering breakthroughs behind the F-117 continue to shape the future of aviation. That's all for today's video. I hope you liked the video. Subscribe and hit the bell icon for more updates. Thanks for watching.